In our next section that we're going to cover, we are still looking at those derived units from the metric system, and we're still looking at how we can use those derived units. Now for density, we're not going to be doing converting. We're actually going to be doing solving. Density is a derived unit that is a ratio of mass to volume. What you can think about when you're thinking about density is an object that is very light or very heavy for its size. So imagine this. If you were to compare a soccer ball to a kettlebell, have you guys used a kettlebell before? If you were to compare a soccer ball to a kettlebell, although they might be relatively the same in size, their weight is very different. Meaning the soccer ball has less weight per volume, it is less dense, where a kettlebell has more weight per volume, it is more dense. If you've ever gone to pick up maybe a box, right, a cardboard box, and you thought it was going to be really heavy, and so you bent down and you lift it up and it was super light and it was really easy to lift, or maybe you thought the box was going to be really light and so you bend down to lift it up and you kind of tug and it doesn't really go anywhere. Those are functions of density, right? Same size box, different weight. So its density has changed. So one of the ways we can recognize materials in chemistry is by their density. Two items might look very similar, but we can tell them apart based off of their density, their mass to volume ratio. So what we're going to do right now, we're going to practice a couple of density problems. We're going to learn the 5-step method for solving problems, and that's something that's going to kind of follow you through the rest of the semester. And then we're even going to learn how to use density to identify a material. So we're going to do all of those kinds of things in the next little bit here. So we're going to start with just a plain old density problem. The problem asks, what is the density of an 853 gram block of marble that occupies a volume of 310 centimeters cubed? So it's an important thing to note up here that the units of volume can be centimeters cubed or milliliters, are kind of the standard ones that you would see, although you could have liters if you wanted. And mass is going to be in either grams or kilograms, would be acceptable units for mass. So when you're reading the problem and you see that it's an 853 gram block of marble, you know that 853 is a mass because the unit gram is sitting there next to it. So when we start the 5-step method, we start by identifying what is given in the problem and what are we asked to find. So in this problem, we are given an 853 gram block of marble. That 853 grams is a mass, so I would plug in M equals 853 grams. This is a really fundamental part of the 5-step method. You need to identify what variable that you might find in the equation is the value that you were given in the problem. It occupies a volume of 310 centimeters. That was a little easier because it said it occupies a volume. That's how you know that 310 is a volume, okay? So now, what are we trying to find? Well, we're trying to find density. So step 1 given, step 2 find, step 3 use. What are we going to use? Well, we have a pretty easy task with this because we only really know one equation, D equals M over V. Density equals mass over volume. So given, find, use. I can see that I have mass and volume. I'm trying to find density. Don't need to do any conversions to be ready to plug into this. I'm ready to just plug in. That's step 4. So in step 4, we just simply plug into our equation. So I'm going to say density, D, equals mass, 853 grams, over volume, 310 centimeters. And step 5 is just solve. Now, I'm not going to have you show me the stepwise solution. That's something really for math class. What I'm concerned about is that after you've plugged it in, you give me the answer. So you can go to your calculator and plug in 853 divided by 310, and you're going to get 2.7516 or 2.75. So we say D equals 2.75, and the units did not cancel. So they hold, they stay. Gram per centimeter cubed. This is the density of the block of marble that you were given. So for this next problem, we're going to be using the same equation, but most importantly, the same 5-step method to solve our next problem. So this one says diamond has a density of 3.26 grams per centimeter cubed. What is the mass of a 0.35 centimeter cubed piece of diamond? So in this time, we're trying to find mass. And one of the things that we like to do is figure out what the units of mass will be before we even get started. So what do you think the units of mass will be? Look at the density, 3.26 grams per centimeter cubed. What would the mass be? Well, mass is measured in either grams or kilograms. And in this case, it's in grams because we see that in the top of our density. The reason why this matters is because what you should do now is go put that unit at the very ends. I'm going to show you how I grade this in just a moment, but you want to go put that unit at the very end. So given, I have, my first given is density is 3.26 grams per centimeter cubed. And I also know my volume. The volume of this piece of diamond is 0.35 centimeters. So we're still talking about a density problem, so we're still going to use our D equals M over V equation. And now we just go ahead and plug in what we know. So my density, 3.26, is equal to, I need to include my units, so 3.26 grams per centimeter cubed equals my mass over my volume, 0.35 centimeters cubed. Now, in order to solve this, you can use like cross multiply if that helps you, or you can just know that you're going to multiply both sides by 0.35. In order to solve this, what you're going to do is you're going to do 3.26 times 0.35, and you're going to end up with 1.14 grams. 1.14 grams. And you can always check to see if this is the right answer. First of all, we can see that our units are going to cancel and be left with grams, so that's good. So I know that that unit is correct. Secondly, I could always check it by plugging it back in. So if I have 1.14 divided by 0.35, I should get 3.26. And I do get 3.26. So I know that my answer is correct. This last one, what is the volume of 76.2 grams of mercury? I want you to finish solving this in your notes. I want you to put the answer at the end of the Edpuzzle, and we will go over this problem in class tomorrow because it requires a little bit of algebra that I want to make sure you're all getting. So I'll see you in class tomorrow, and we will go over number 3. What is the volume of 7.26 grams of mercury that has a density of 13.6 grams per mil? Talk to you tomorrow.